சொன்னாருன்னு அது வந்து ஆர்கிடெக்சரல் டெக்கரேட்டிவ் கான்கிரீட்டிங் டெக்கரேட்டிவ் அதில் வந்து ஒரு கொஸ்டின் நான் கேட்டிருந்தேன் நான் அது வந்து இப்போ அந்த டிசைன் வந்து டெக்கரேட்னா அந்த காலம் பீம்லாம் இட் ஓன்ட் பி ரெகுலர் ஷேப் அந்த டெக்கரேட்டிவ் பாயிண்ட் ஆஃப் வியூல கொஞ்சம் ஷேப்ஸ் டிஃப்ரெண்ட்டாக இருக்கலாம். So it gives both structural as well as decorative purpose. That's yesterday they had a class and it is a webinar.
Okay.
Now my question was, how do you design such type of we have the delta square, round, rectangular, regular shaped members design we have done it, but here comes where the shape of the members are decorative nature apart from structural. So you must take structural aspect and also decorative aspect. So upon the modeling of this such type of complex how do we do the design? Is it do manually do it, or we can do it with the
normally the decorative concrete will be prepared with 6 mm chips, cement 6 mm chips and mixer, not with 20 mm thickness aggregate. They will not use. So, also it is not cast. It is cast in situ, but it is not together coming as a concrete member. It is a separate first concrete member column or beam will be casted. After that, separate shuttering for that decorative work will be made. Then it will be poured slowly with that 6 mm chips concrete and then molded. So it is separate.
Okay. So the structure, the decorative one won't take the load.
Design wise, the weight of the decorative work we have to calculate approximately and then consider in over the beam or above the column in axial way or maybe in flexural way or compressive way, whatever it may be. We have to calculate that approximately the decorative works and include in our design.
So the decorative won't take the load. The decorative one won't take the load.
It will not take load. It's just decorative only.
Okay. I got it.
Okay, sir. What else we have? I think, yeah. Okay, in last class, you've seen about this. Sorry. Okay. So I think last class you have seen about the wind loading, and then we completed also the dead load, structural dead load, floor finish dead load, and services dead load also we completed. Now come to wall load. So wall load we should apply on the beam, not on the slab surface. So wall load generally if you see 3 meter height, so 230 thickness example, so 0.23 3 meter height into 1 meter wide. We will calculate first for 1 meter wide. That is called UDL. No, every 1 meter is a UDL. 1 meter long, 3 meter height, 0.23 wide. So this is a cubic meter totally. How much it is coming? Sorry, 0.23 multiplied by 3 meter height, 1 meter long. It is 0.69 cubic meter. So what is the unit weight of brickwork? Brickwork unit weight is as per IS 875 part 3. Sorry, IS 875 part 1. Let's say this brick is okay, let us search for brick. Okay, common clay burnt bricks means it is 18.85. Engineering bricks means it is weight is per meter cube it is 21.2. Heavy duty bricks, pressed bricks, refractory bricks, sand clements. There is one more aerated bricks also nowadays coming, but it is not there in this IS code. There is a light duty aerated bricks also coming nowadays. That is very, very light bricks also, maybe 6 or 7 kilonewton per meter cube. So
out of these three, the common burn clay
sorry, sir.
15.7, 21.24, 24.250. Which one you have to use, sir?
One minute, sir. Aerated cement bricks. It will be something like this. Or lightweight bricks. AAC block. It's called AAC block, advanced aerated cement blocks. Okay. So the unit weight of see here 40 pounds or 650 kilogram per 650 kilogram per meter cube. Very, very small. No. So normal brick is around 2500 kilogram because 25, no, 25, 24 kilonewton, 1 meter cube concrete. No. So aerated brick means only 650 only. 650 kilogram means you can say how much it is saying 18.85 kilonewton, right? It is normal 18.85 for normal brick, clay brick. Engineer brick is 24, heavy duty engineer brick, almost like concrete weight per meter cube. Okay, now this is 650 means only 6 kilonewton per meter cube. So nowadays people use this 6.5 kilonewton per meter cube, which is 650 kilogram approximately. This brick is AAC block, lightweight bricks. Why they use this bricks? Because when they use this brick, what happened? No, your durability, everything is same. Only thing is the weight of the entire structure will get reduced. Imagine if the beam's weight, the wall weight above the beam is reduced, then what will happen? Beam size will be smaller. Imagine if the same weight is transferred to the column also getting less axial force, footing also become less. So all the sizes of beam, column and footing will become small if you use aerated lightweight bricks. Okay. If you are using heavy bricks, then all become very big. Beam, column, footing all become very big sizes. So if you become smaller size means it's minimizing the cost, no? Cost minimization. For the purpose, AAC bricks they use. So for this example, let us use this 18.85 clay brick. So multiply with, this is a cubic meter for 1 meter long. Multiply it with 18.85 kilonewton per meter cube. So 13 kilonewton per meter is a UDL load. You can go here, the wall load, add a new load. It's a member load. Member means beam load. Before we were using this plate load. Plate means a slab and ours. Now you have to use member load. Nodal load means joint load. Member load is a beam load. Even though it shows a steel beam here, doesn't matter. It is just a pictorial representation only. It can be for a steel beam and RCC also. So it is showing the picture is just steel beam. Don't worry about it. Okay. This is a uniform force, uniform moment, concentrated force in one location beam. So there are many type of trapezoidal load, everything is there. But we need UDL load. UDL means uniform load, uniform force. You can put here how many kilonewton per meter cube. We already calculated 13, no? We calculated 13.00, 13 kilonewton per meter. What is D1, D2, D3? D1 it is mentioned here. D1 is if you want from starting of the beam some offset, you can input offset here. D1. D2 means after the D1 point, how much length load you want. So that load, if you want, how much length of the load is applicable. Maybe in some beam center only there is a load. In any case, so you can apply that also. Customize it. D3 is the distance from the edge of the beam to the center. So if it is any offset is there in that also, you can enter that loading information. But generally we will not use this in our building because Most of the cases we will construct the wall at the exactly center and all over the length with no offset. So that's why 0, 0, 0. 0 offset, entire length. So like that. Okay. Just enter 13 and GY. But while entering, you have to enter minus 13 because global Y direction is a reverse load, minus direct. But is added. So for which beams you will assign this one? You have to assign for, you have to select first all these beams. But for certain beams here not required wall, some not required wall. So you have to deselect wherever that is not required. Select first, then deselect. Also columns also not required. Beams. So you can deselect the columns also, right? So better you select like this. Beams parallel to X. Beams parallel to Z. Like that, if you select, all will be all beams, beam and group beam and all beams comes. And then wherever you don't want, you can deselect it.
How do you deselect, sir? How do you deselect?
You have to press the control and click one by one manually like this.
Okay. Control.
Press control and deselect. Here it is not 13, maybe 6.5, 6.5. So better deselect this also. Manually one by one we have to do. Also here also. Because 6.5, 6.5. So deselect this also. Very important is you have to press the control. If you leave the control, it will again you have to select. E-tabs not required to press control. Directly you can click one by one, it will be deselecting. But here you have to press the control switch, control button in your system, then deselect wherever you don't want. So these are all not much user friendly, I know. E-tabs is more user friendly options and everything. Okay.
Raghu,
Okay.
doubt, you're using common bricks. There are other
Hmm.
bricks called engineering bricks and heavy duty bricks. Now, one I was constructing with my friend, I insisted that you must use that heavy duty, which is a machine press, hydraulical machine press, like
Mhm.
very compact and
Okay.
very strong bricks. No, I
Hmm.
asked them to use it. They used it anyway. So, which one to use? Because you've got three varieties. Uh,
Anything we can use, sir, handmade or machine press. Same, no, as long as you get that compressive strength, that's it.
uh,
As long as you are getting the compressive strength of the brick, normally the compressive strength is sometimes 5 Newton, 5 kilonewton per meter squared. Sorry, 5 Newton per millimeter squared or 6 millimeters. It differs. So, mm, until we get it, it's okay.
okay.
Mm.
So, what the designer has chosen, I have to use that same, isn't it?
Sorry,
Because
sir.
what the designer has chosen in his structural design, I
Mm.
have to use the same because the weight is varying.
Mm. Design engineer can suggest to the client in this
Uh,
condition, can we use these bricks like that? You can select it. Maybe some client they don't know,
uh,
but professional clients, some company clients and other people, they know now. They know everybody that they can use this aerated lightweight concrete brick. But some people, like individual houses people, he may not have some well knowledge on engineering, civil or something. he will not have any idea. So we can suggest saying that please see that he will be. You can use this lightweight concrete brick so that your entire cost of the concrete cost, even steel cost of the entire building will be reduced. So if you agree, then fine, we can use it. What is the purpose of this brick? It is not going to take any load. It is just weather protection only. That's it. No, it will not allow you the heat. It will not allow you the cold or warm, whatever will be the condition. That's it. That is the job of the brick. No, so better use lightweight bricks so that your entire material cost, concrete and steel, will be reduced in any building. So now we selected all the plinth beam and roof beam. We apply to the selected beams and then assign. So this is our wall load. Services dead load, wall load. Okay. So it is around 13 kilonewton per kilonewton per meter. If there is any wall less than 13, you can add some more wall load also if you want in the geometry. Again, come to loading. Suppose you need some wall load here. Anyway, we added wall load here, 13. 13 means for the entire height. So it is okay, no problem. But this beam is a dummy beam. Not much. Same beam it is going to give it. No problem. So no need to separately add something. It is better. Dummy beam means just to take the weight of the slab and transfer. Wall load, yes, of course it will come, but it is going to transfer to the both side. No, if you apply separately 6.5, 6.5 for all location, that is good also. I'm not saying that is bad. That is good also. So you can split if you want. 1 minute, sir. Just 1 minute. Okay. Yes. Okay. Okay, right, fine. Now, after finishing this wall load, we'll go to live load. Live load same as floor finish. So I am copying this floor finish, all the members here. Copy. Okay. So paste in live load. But before that, we need to add the live load, plate load. So minus 1.5. That is our live load as per IS 875 part 2. Added plate assigned to list. I copied the list from floor finish. Same list of slabs I'm assigning. So it become 2 and 1.5 and wall load like that. Okay. So this also has come. All live load also we covered. So what else load will be missing here? The we have to draw the headroom and equipment room water tank. No, those loads are missing. We'll draw first and then add it that. And one more thing is this wall load. This top floor, this much is not there. Maybe only very small, 1 meter height parapet only. But conservatively, you can leave it as it is. No problem. It can be a conservative method.
Okay.
What if you reduce from 13 to 4? No, it's okay. Maybe in future, if you need any future expansion or something of one floor, it is better to keep as conservatively top floor also same. Even intermediate also for future purpose if there is anything. You can keep it as it is for future purpose. So maybe in future, maybe you say you will construct one small washman room here or anything for the something. No, maybe if any expansion happens, better to keep same load. Don't modify everything. If you modify also okay accurately. If you don't have any plan, If we don't modify also, okay. Okay. Right, fine. So now we will model the headroom and other water tank and everything, equipment room, everything now. So for the headroom and water tank, you have to select node cursor. From there you select first 4 points and take these 4 points. You selected now, and then we will be extending to 2.5 meter and 2.5 meter for water tank. So go to geometry, this one, translational repeat in y direction. You want how much? 2.5 meter. Okay, 2 steps, 2.5 meter. And you can link with the beams, column, everything. Just 2.5, 2.5. Okay, so it is now linked, and you can add beam also here for the beams or water tank and and then if you need to plates also, you can select 3 plate and then control C, control V, 3 meter, 2.5 meter above in y direction. Click OK. It is not done. It is done now. Okay, done. Yes. Why too low? Two different nodes come. Wait a minute, sir. We will see in the view. It is okay. No big problem. Okay. Analytical model geometry. It is seems two nodes, no? This. This one is not copied here. Maybe.
Yeah, the height is different. Sir.
Height difference is there. Height difference is there. Better we undo and do ourselves. That is the best way. Height difference problem. That's why it is coming like this. Okay, 2.5 meter. Next is extend here. Geometry. In minus Z direction. Minus 2.5. Okay. And then draw ourselves the plates. Now, because of height difference, it doesn't go wrong. Okay. Now we will see in the view. Maybe this floor not required, only this is required for equipment room. We will see. Just come, but backside not come. Go to model backside, and this floor not required. Live plate pressure. Also not required. Okay, this is required for the water tank. Yeah, we have to draw.
So delete you have to give from keyboard, sir. Delete.
I delete from keyboard only, sir. After selecting keyboard only. Save. We'll see now view. I think now it is okay. Okay, only thing is we have to add the properties now. We have to give the properties of this plate, and one more slab we have to put it here. The slab and properties of beams and column we have to give it. So properties of one more slab we will add first here for the equipment room base. Done. Now we'll go to properties. Properties, plate 25, we'll add it here. Zoom it. Add for select cursor plate. This one, and this one, and this one also we'll give plate 25. Okay, and then column size, this one we'll give the same column size too. So actually this should have been done better during our seismic loading, no weight, joint weight time. That's it. Itself it is better to model this also. Anyway, it's a very small entity, no, it's not a big thing. Beam. Anyway, it's okay now. We will view once again in 3D. Okay. So almost. It's okay. Anyway, there is no wall because we don't have wall model, but slab is required for here and there and top also. So that slab also let us draw now. Geometry, add plate, one slab for this top of equipment room, and one slab for that bottom of water tank, and one slab for top of headroom and top of water tank. That's it. So all this slab will be use the select cursor. This slab, bottom slab, and this slab. All the three will be 100 mm thickness I am giving. Okay. I think this slab not. This slab also 100 mm. Bottom and top also. So all we have given. I think now it will be completed. Headroom and okay. Headroom and other thing, everything completed now. Now we'll coming to another loading part now. Load cases, we have added live load, everything. So live load, we can give this 1.5 to this top of select plate cursor, top of this equipment room, also top of the water tank. You can give 1.5. This selected place, assign 1.5. Live load also there because maintenance people will go and work. But for the bottom level loading, but for the water tank, inside the water tank, water pressure will be more. That water pressure we have to give it as a live load. Or you can add separate load for water pressure load, something. Add one more load, primary. Sorry, not here. Load case, add the primary, it's a live load. Fluids load. Or you can say live load only. Live load is fluids load because the water will be always up and down, increasing and decreasing. No? So You can say water load inside water tank. So it's new live load. You can add pressure flow load, let load, but you have to calculate. How to calculate? You should know length, breadth, and height of this one. Height we know 2.5. Length, breadth approximately you can calculate from our drawing. Where is this drawing? Yeah, this is a sample drawing. Modeling. The length, breadth means this is the length. Staircase room length, right? It's a length of the staircase room. So what is the length of staircase room here? Staircase room length is 4.95 meter. Okay, approximately. Center not required, just take 4.95. Outer to outer. 4.95 meter multiplied by the width of staircase room is 1.83. Inner 1.83 multiplied by the height is 2.5 meter water tank height. 2.5. 22.64 kilonewton. So 1 kilonewton is 1000 liter, no? So how to, 22.64 cubic meter. 1 cubic meter is how many kilonewton it is? Water. Unit weight of water, 1000, right? Unit weight of water.
1 meter cube 1 ton.
You see 998 kilogram, it says. You can say 99 kilonewton or 100 kilonewton. So 100 kilonewton per meter cube is the weight of the sun. So it is 22 meter cube into 100 kilonewton. So 2264 kilonewton, 2264 kilonewton this weight of this. But this one you have to divide to the area, no? So what is the area? Area is nothing but divide the area. Then only it will become a pressure, no? So the area will be again divide by 4.95, 1.83. So divide by 4. What is the size? 4 sorry.
It is like another live load, is it?
4.9 live only. 4.95, 1.83. 4.95 again divided by 1.83. So it becomes 250, no? 250 kilonewton per meter square. Is it correct or no? Or we will check once again. We will cross check once again. Just simply the height 2.5 multiplied by the unit weight of water. Unit weight of water is it 100 kilogram or 10 kilogram?
10 kilogram.
We will convert per cubic meter, right? Kilogram per cubic meter to Newton per cubic meter. Okay.
10 kilometer per cubic meter. 10.
Approximately, yeah, we will see. Let's say 100 kilogram per cubic meter. Okay. 100. 100 means 0.98 kilonewton per cubic meter. Is it correct? Correct or no? No.
1000 kg per meter cube, sir. 1000 kg by 100. Yeah, 10 kilonewton per meter cube.
Yeah, it should be 10, but anyway, let's see. There is a converter, sir. Then sometimes this unit get confused. See, let us consider here 100 kilogram per meter cube. Sorry, 1000 kilogram per meter cube. 1000 kilogram per meter cube means 10 kilonewton per meter cube, right? Correct or no?
Yeah.
Okay, 10, approximately 10 kilogram per meter cube, because we have to divide by 10, no? Why by 100? Anyway, so there is a conversion, kilogram per meter cube to kilonewton per 10 kilonewton is okay. 10 is okay. That means 2.5 is the height multiplied by 10 kilonewton per meter cube. So it is around 25 kilonewton per meter square pressure. So is the pressure, because this is in meter. This 10 is in kilonewton per meter cube. So meter cube means it remaining will be kilonewton per meter square, correct? So pressure will be 25 only. So minus 25. Minus 25 pressure in GY direction. We added new. Why I cannot add here? Here, okay.
So minus G1, yeah?
Minus 2.25. Yes. It is minus 25. You have to select the plate cursor. At the bottom of water tank slab, we have to give this water tank water load. Assign. Okay. This is a water tank, water height, water weight, live load. Everything is there. No? So water tank load finish. Now coming back to our equipment weight. So let us assume our equipment is 2.5 ton. Equipment weight. Equipment means lift equipment. So generally the lift equipment will be sometime 1.5 ton, 2.5 ton, depends upon the size and number of passengers and other things. So let us assume in this case, actually this information should be got from mechanical engineer. Mechanical engineer input. Yes, input. So let us assume in this case it's 2.5 tons. Okay, 2.5 tons means 2,500 kilogram. So how many kilonewton? 25 kilonewton, no? Right or no? 25 kilonewton, no?
No, 25,000. So yeah, 25 kilonewton, yeah, correct.
kg to kilonewton. You can use Google if you want. See here. So kg to kilonewton. If you enter 2,500 kilogram, it is 24 kilonewton or 25. You can say 25 kilonewton. 25 kilonewtons is equal to 25 kilonewton. This equipment we assumed 2.5 tons, 2,500 kg equipment. How much pressure it will give to the slab where it is mounting? So pressure is equal to what is the area of slab it is getting mounted? Area of equipment room. Equipment room slab is equal to 2.58. This one is 2.5 by 2.5. No, the distance is 2.5, 2.5. I remember, not 2.5. This is 2.5. This side is in the plan. It is there. In the plan, it is 1.83. So 2.5 we extended and 1.83. So the area of room is 2.5. 2.5 multiplied by 1.83. 4.5 meters square. This is the area. 2.5 by 1.83, which is equal to 4.5 meters square. This is the area. So how do you know you have the weight of this equipment? Okay, weight of equipment, and you have the pressure area where equipment is getting loaded, the maximum bigger area. So how to calculate pressure? This is a load. This is area, right? So pressure is equal to load by area. Simply 25 kilonewton divided by 4.5 meter square. So unit kilonewton per meter square will come. So how much kilonewton per meter square? 4.5. You can put 1 by x into 24. Sorry. 4.5. 4.5. Oh, sorry. 25 kilonewton divided by 4.5, correct? 25 kilonewton divided by 4.5. So 5.55 kilonewton per meter square. 5.55 kilonewton per meter square. This is a lift equipment weight. Where we have to apply? We have to apply in this bottom surface, this surface. Because above is a room closure. Here only there is a slab. Above there is no slab any level because equipment cabin will be moving here. So this place we can give equipment loading. So that equipment loading is a dead load. Okay, so dead load you can add one more dead load. Okay, so add dead load or super dead also. There is no super dead, no. No dead. Okay, so dead load. Let's say so it is lift equipment dead load. And dead load. Okay. So lift load, how much it is? Plate load. Plate load 5.55, no? Minus 5.55 in GY direction. Right? Okay. And add this load, and this is selected place, select plate and assign. Okay, define, assign everything very quickly we are doing. Okay. So water tank load, lift equipment is done. After that, what are the loads are remaining? Remaining is your lift cabin weight load. But in Staad Pro, we do not have any nodes here, joints. Since there is no joint here, we have to create the joints everywhere and then apply that equipment load. What is equipment load? Equipment stopping load. Because if you have a shear wall, this is a shear wall. Normally what it will be done, here it will be door, no? So every floor there will be a door here. So come out. This door will go open automatically and close it here. So this is some foldable type system, something will be there here to go in and out. So it's a foldable type door. So every floor it will fold and open and do it. But the cabin will be, there will be a channel here. Fixed channel will be there. Channel are not angles, mostly C channels. Will fix. In that the cabin will be fixed like this to move up and down with the gaps. So this is a cabin, lift cabin. Whenever every floor comes, it will stop here and then move. So this lift cabin will be fitted with many type of roller on the both sides. It will be rolling up and down with chain pulley. So there will be a chain counter pulley also will be coming with many location. There is a chain pulley also coming from top to bottom, everything going. Main thing this lift cabin. So the lift cabin will be whenever the floor comes. So let's say this 8th floor. 8th floor comes, it will stop here for a while. So while stopping, what happened? This shear wall gets some point load here. When it is moving, no much load to this wall because it's simply moving on the rails. No much load on the wall, but only thing is there is a vibration front, back, and vibration there. These vibrations, this rolling, moving load will be given by our equipment vendor. If this moving load will be given, it is fine. If not, normally he will say that apply some uh, member load or point load on this channel location. Some load you will be giving 5 kilometer, 1 kilometer, something like that. So it's again this input, how much loading is going to come in every location while moving or while standing also. Whatever the input he is giving, he has to apply. Let's say approximately this stopping load may be biggest load at the top level and bottom level. Remaining all level, there will be a very small load for stopping. Permanent stopping will be either at top floor or bottom floor. Some new lift design nowadays it is coming with also every floor, maybe it can be a permanent. If somebody is in 5th floor, stop and went, maybe 1 hour there is people are not using lift, it will be stopping in 5th floor only. But olden days it was 5th floor, if dropped, nobody's for next 5 minutes, it will go to the either top or bottom for resting. If pressed only, it will come. But nowadays the system has been changed. Many people, they will be applying, they will be designing this lift with every floor. One permanent stop page can be also there. So approximately, let's say in the both joint, here one joint and both joint, maybe for 2 kilonewton. Approximately, if this input will be by mechanical engineer, again vendor, lift vendor. So lift vendor, he will provide this, how much reactions of this cabin. So 2 kilonewton means around 200 kilogram here and 200 kilogram here. No? So it's a big load, 400 kilogram load with the cabin. With people also sometime all together. Maybe 3 kilonewton or 4 kilonewton it will be given by him. Sometime 5 kilonewton also because it depends on the size of the lift. So approximately, we will take this for exercise 2 kilonewton here. For future, we have to get from lift vendor this. Some cabin may be So now 2 kilonewton means how much is the total weight of the cabin? 2 plus 2, 4 kilonewton, 400. 400 reaction. 400 means 400 kilogram. 400 kilogram means 5 persons, right? 4 persons. 4 persons, maybe 3 persons with the cabin weight, something like that. Like that. No, sometime the vendor will give, if it is bigger cabin, maybe 5 kilonewton also you can give, or 3 kilonewton, 4 kilonewton also you can give. So this exercise, let us proceed with this weight. Actually, we have to get from them. So every stop location, we have to enter this for 2 kilonewton as a point load because it's stopping here. Apart from this point load stopping, while moving, there is some load will be there. That load we have to apply in this channel separately. Moving load, this channel. No, we have to apply the moving load in this channel also. But this moving load will be in a UDL load. Generally, UDL load you will give UDL load. Let's say 5 kilonewton per meter, something like that you will give, or 2 kilonewton per meter. It depends upon the weight of this cabin. So that moving load we have to apply in this channel also while going UDL load, and stopping load as a joint load in the shear wall. But this channel we will not design. No, the channel will be designed by vendor. So this moving load, whatever it may be, it will be taken care by vendor. Vendor will apply the moving load and take the sizing of this channel will be supplied by him. So sizing is by him. We much not required to worry on this. But this channel will transfer that moving load to the concrete wall. Why concrete wall required? I think we explained in our practical structural design, manual design, and so many locations also in ETAPS course also, that this equipment carrying structures always will have any vibration on X, Y, Z vertical directions. So that time if you have a brick wall means it will give, the vibration will make the bricks to crack, and then slowly one by one brick will be falling. The structure, the brick wall will be damaging. So for that purpose we will be having concrete wall for always in the lift. Not only lift, wherever equipment handling units. If you want in RCC, by RCC only, not any bricks or no any timber or other things. Always it will be in RCC, reinforced concrete only. So that's why shear wall required. So moving load, even though it is designed by vendor, you will design the size of the channel. Okay. So but this channel moving load reactions or any effects of this moving load will be applicable to even this wall also. So what we need to do is, generally with this UDL load we have to apply on the centroid of the wall also. So let us use this 2 kilonewton per meter, and this we will try to apply the centroidal way. You see what happens. Okay. So this 2 kilonewton and 2 kilonewton per meter wall, both we will try to apply in this model. For that you need to have a joint first. So before going to joint, let us apply the UDL load, equipment lift load. This is finished now. Equipment load is finished, that load, and it comes under live load. So live load separately we'll add one load for equipment live load. Equipment dead we have added already. Equipment live load we will add. Live equipment live lift equipment live for cabin. Cabin load. So this one will add two type of load. One is joint load. Joint load in y direction minus 2 kilonewton. This is one thing. Second thing is UDL load as a plate load. We'll use a plate load. Plate load concentration. Yeah, plate load pressure not required. I don't see any. Yeah, pressure load is okay, but it will be for entire plate. The center will be there. Partial plate pressure. Partial plate pressure, we can use it. So partial plate pressure, the pressure will be in G. What is the direction? The pressure means it is in this direction. So plus X minus X direction it will be. So plus X direction Gx, we will see partial pressure of we will convert UDL into pressure. So this is 2 kilonewton meter. Okay, how to convert into pressure? So if it is kilonewton per meter, you want to convert into pressure means what you need to do? You have to multiply by, you have to divide by the wide. So divide by the wide meter, wide of the angle or channel, whatever maybe, you will get a pressure. Okay, so this is dividing by the wide. So it becomes m by 1. When we go up, it will become kilonewton per meter square. So divide the wide of the channel wide. So let's say this channel is 5 inches channel. 5 inches means 125 mm, 0.125 meter. So divide this 2 kilonewton meter divided by 0.125. So what is the pressure? Pressure will be 2 kilonewton by 0.125. So it means approximately 2 divided by 0.125. So 16 kilonewton per meter square. 16 kilonewton per meter square. It is in a x direction. We will finish just in 5 minutes. So 16 kilonewton per meter square in a minus x and plus x, both you have to do. Gx minus x plus x. What is xy1? What is x1, x2, y1, y2? X1, x2, y1, y2 is the offsets, loading area, offsets. How much x1, y1? X1, y1 means how much from x from here and y from here. How much x2, y2? X2 means from this side how much and this side how much. Both side, both end, no? So from here, let us say this distance is 2.5. The wall wide is 2.5, no? Where is the wall? This wall wide is 2.5. In this 2.5, in center, let's say of 125 mm. So that means 2.5 minus 125 mm. 2.5 means 2500 mm minus 125 mm. Okay, divide by 2. That's both sides. So 1187. 1.187 approximately. This will be 1.187. Next to also 1.187. Y direction, there is no any offset. It is a completely going straight, right? We keep it as it is, plus x. The area of the, okay, it is asking the wide in y. Y wide is 0.125, no? To y. 125, 5 inches. X and y, this is offset centrically. Area of the load pattern is 0. Command has been included. Area of the load pattern is 0. We will first apply for 0, 0 and see later we can modify. I think it is not working. Plate load. So let us give pressure. That is better. Now, what is the pressure coming overall? 16 kilonewton per meter square. The pressure. 16 kilonewton per meter square in Gx. We will see. Then we will curtail it. And one more is plate load. Here you have to model the dummy beam and give, but dummy beam again will give problem in minus 16. Dummy beam will give problem in running analysis. There is a lot of problem will come. So x direction plus 16 minus 16 we will see 16 kilogram per meter square, around 1600 kilogram. Very big, no? We will see this design. First Fy for live load. We need the joints here. So next class we will see how to create the joints for this Fy, and then this pressure. Pressure applying is plus 16 is easy. This side all plus 16.
So that's a moving load.
It's a moving load, yes, sir. Which all are plus 16. Okay. And minus 16 the other side.
moving load will be again perpendicular to the shear wall.
Correct, sir. Correct. I think this also minus 16. This minus 16. Yes. This is minus 16. Reverse now from inside to outside. This side it is pushing this side. This lift minus 16, and this one will be pushing this side plus 16. Yes. This will be plus 16. Pushing outside. Plus 16. We'll use this other. We'll go to plan view and use it. Select all the plates from plan view like this. Other side, then use this plus 16 like this. Plus 16 minus 16. So it is both side pushing, right? This side and this side, both side is moving load. So this moving load, actually it is not for the entire wide, but it is better you apply conservatively. Actually should be for center only. And next class I will try to modify. I will teach you. I will keep verify that very minimum area load. Then we will see what happens. So this next class you will see how to model the joints in every location. Just simply we have to model the joint here, and that joint you have to apply the. But if you yeah, we can apply. We will see how possible is this one. Then our entire loading will be finished. After that we will be going for loading combination. After finish this one, next class we will finish this 2 kN one. We have not assigned this one, still question mark. We have to model the joint and assign that 2 kN as a point load.
Point load, unless you make a joint, you can't do it, isn't it? Point load, you can only apply.
Unless we don't have joint, we cannot do. We cannot do. We don't have any such option to.
But real after making joint,
there is no such any option for plate load. Concentrated plate load is there, but it is I think concentrated plate load on GY direction also is there. Yeah, better we use this one. GY direction minus 2 kN. Better we use this one. We'll add. We'll try this 2 kN on. Yeah, 2 kN on this one. So 2 kN means how much it is? This both plates. These plates also we need. This one assign to list. Okay, I think it is working well. Good. Concentrated load. And other plates
at each level, sir.
Yes, each level. Yes. Another plate list also from that plate load, pressure load. We'll add it here. Once again, we are adding and assigning. I think this is same. Other load is others are this one. Copy and assign. So both side is 2 kN is from here and here both side. No. So both side we added this cabin stop. This one we will delete it.
Same way moving load, sir. Moving load you can apply on the center like UDL.
Yeah, I will check. Apply on center, but not
as UDL load.
It's a point load we can apply. UDL load I will check. Where is it? There is a new version. No, we have to check. I will check and keep ready. Next class I will teach. And then we'll proceed for our entire.
This one, sir. This the cube not this crane one. Maybe you're going to just brief it again next class.
Crane load, no? Okay, no problem. No problem.
Crane is lift, and the moving load and the point load. Just to recap it again, please.
No problem. Okay. Okay. Sure, no problem. Okay, thank you everyone. We'll send the video. Thank you also.